Okay, so you use this stuff every single day, but have you ever stopped to think about the real secret that separates, say, your toaster from your smartphone? Today, we are going to dig into the difference between power that just works and power that actually thinks. Let's get into it. Right, think about it. A toaster and a smartphone. They both need electricity to do their thing, but one just gets hot, right? While the other, well, it can connect you to basically anyone on the entire planet. So what is the fundamental secret that separates these two? That's the puzzle we're going to solve today. All right, first up, let's talk about the heavy lifters. This is the world of raw brute force power. It's where electricity is used for really straightforward physical jobs. Welcome to the world of electrical devices. And the definition here is actually beautiful in its simplicity. An electrical device is all about one thing: energy conversion. It grabs electricity and turns it into something you can see or feel, like motion, heat, or light. You can really think of it as the muscle of our tech world. You know, we're talking about things like giant industrial motors moving things on a conveyor belt, or heaters that warm up a whole room, or even just a simple light bulb. They all do the same kind of thing. They take in electricity and perform one direct physical job. That's it. But now we get to cross over to the other side. And over here, it's not about raw power anymore. It's about information, it's about logic, and it's about control. This is the world of electronic devices, and believe me, it is a total game changer. And this right here is where it all clicks. This slide just lays it all out. On one side, you've got brute force, doing physical work, and on the other, you've got intelligence, processing information. See, electrical devices just let the power flow through, but electronic devices, they manage that flow with unbelievable precision. Yeah, and this quote really just nails it. The magic word, the most important word here, is intelligently. It's not about how much power you're using, it's about the complexity of the control you have over it. So the big question is, how on earth do they do that? Well, the answer lies in one of the most incredible inventions of the 20th century. It is the tiny, unsung hero hiding inside every single smart device you own. It's time for us to meet the transistor. So what is this thing? At its heart, a transistor is this microscopic little component that has two main jobs. It can act like a crazy fast light switch, turning a current on or off in a flash, or it can act like a megaphone, taking a tiny weak signal and making it big and strong. Let's just focus on its job as a switch for a second. Think of part of the transistor as a gatekeeper. When a tiny little electrical signal shows up, that gatekeeper opens the gate. And that simple action allows a much, much bigger current to come rushing through. And as soon as you take that small signal away, the gate slams shut. It's an incredibly simple but powerful control system. Okay, now here is where it gets absolutely mind-boggling. A single modern computer chip, that tiny little brain inside your phone or your computer, it doesn't just have one of these switches. It has billions of them. Billions! We're talking more transistors on a chip smaller than your thumbnail than there are people on planet Earth. And they're all opening and closing at unbelievable speeds. So how in the world do we get from a simple little on-off switch to you sending a text message or watching this explainer right now? Come on, let's connect the dots from that tiny transistor all the way to the world we live in today. You see, every single one of those billions of switches represents a simple decision. It's either on or it's off. And we call that binary, a language of ones and zeros. Every photo you take, every song you listen to, every single line of code is, at its most basic level, just a gigantic, complex sequence of these ones and zeros. And all that processing power is what allows for automation. Think about a smart home device, like a thermostat. A sensor in it detects a change. Maybe the temperature drops or it senses motion. An electronic circuit inside processes that signal, checks it against the setting you programmed, and then tells the heating system to turn on. It's a perfect loop: sensing, thinking, and then acting. All thanks to electronics. But these circuits, they do more than just switch things on and off. They have other really critical jobs. Amplification, for example, that's like turning up the volume on a weak radio signal so you can actually hear it. Control is that smart thermostat logic we were just talking about. And rectification, that one's super important. It's what converts the AC power from your wall outlet into the DC power your phone's battery needs to charge. Okay, so let's zoom out for a second, because this is way bigger than just cool gadgets. This ability to intelligently control electricity has literally reshaped our entire civilization. I mean, what does this actually look like in our world? It's the internet. It's the smartphone in your hand, with its powerful microprocessor brain and all its little sensors. It's the industrial robots in factories building things with perfect precision. It's the MRI machines and hospitals that let us see inside the human body. It's even in our cars, like the braking system that makes a split-second decision to keep you safe. So here's the bottom line. Electronics isn't just a category of stuff you can buy. It has become a foundational pillar of our modern life. It's the engine that is driving progress in almost every field you can possibly imagine. And all of this leaves us with a really fascinating question to think about. We've figured out how to control electricity to process information and automate our world. So the question isn't if we can control it anymore. It's what new, maybe even unimaginable tasks are we going to teach it to perform next?